Okay. So welcome everyone to this second workshop in which we will demonstrate how to publish assets and how to consume assets in the Ocean Enterprise marketplace, as well as to how to run computer data jobs. We will start with a very short presentation for each of these topics, and then I will jump right into the demo. Okay. Then, in the first part, we will demonstrate the publishing and consuming of the assets. That's why we will begin with discussing a bit about what an asset is, what a service of an asset represents. And in the second part, I will very briefly present you some of the concepts related to running computer data jobs, and then we'll jump into the second demo. So let's begin with assets and services. What is an asset? What is a service? The asset in Ocean Enterprise represents the intellectual property that is registered by a publisher, while the service attached to the asset represents the way the asset is accessed. An asset can have one or more services, each one having its own price, each one having its own validity period, and each one having its own access control defined. This is an example, for instance, of how you can define access to an asset. Here we have three services. Each service represents basically the same asset, but the first service will allow the user access to the asset for 1 hour, and it has a price of €1. Second one will allow access for 1 day, and it's priced differently, €10. And the last one will allow you unlimited access, so you are not limited in time how to access the asset with a different price. Basically, by defining the services and setting the pricing schemes and access controls, you can very easily define the various, let's say, marketing proposals for the assets that you register in Ocean Enterprise. Let's move on. Sorry. We have two different types of assets in Ocean Enterprise. We have data sets, which basically represent various content. Either is a list of records, or a video, or an image, or whatever you want to register as an asset, or algorithms. The distinction between algorithms and dataset is when it comes to computer data, because algorithms are the programs that are executed on top of data set. That's the only difference between an algorithm and a data set. Because, of course, an algorithm is also stored in a file that is accessible through a link, let's say. Then we should also discuss about access types to assets. So when you create an asset, you have to define if the asset is either available for download or for compute. If it's available for download, what does it mean? When a consumer buys the asset, it will actually download the file that is behind that asset. If the asset is created for compute, the consumer will not be able to download the asset, but it will allow the consumer to run an algorithm on that file and retrieve the results. So the consumer will not actually see the content of the asset, but can benefit of the result of running an algorithm on top of that asset. And we should also mention the asset hosting types. Okay. Okay. Asset hosting types means where the file that is served by that asset is actually located. So when you register an asset, you can specify the location of the file, of the actual file that is served by that asset, to be either accessible through HTTP, or it is stored on an FTP server, or in IPFS, or in an S3 bucket, or is available query in GraphQL. And we'll see when we will publish an asset exactly what I mean by this asset hosting types. And the last thing that we will cover here in the theoretical part of this workshop is access control credentials. So basically, when a consumer tries to access an asset, he needs to be allowed to access the asset. So the way that the consumer present its the way that the consumer is verified if it's allowed or not is based on two things: either on Web3 addresses, so that means that the Web3 address of the consumer, it should be on the allow list of that asset, or it should not be on the deny list of that asset. That's one type of credentials, Web3 based. The second one, the second type of credentials are based on SSI policies. What does it mean? In order for a consumer to access a resource, the consumer needs to present one or more verifiable credentials that comply with the defined access policies in the asset. I will not insist on SSI right now because there are too many things to cover, and probably it will be better to do it in a dedicated workshop. So with that being said, I will just briefly go through the publishing steps that are currently defined in Ocean Enterprise Market, and then I will jump into the demo. So the publishing steps are quite simple. First, you need to define the metadata of the asset, to specify the credentials needed at asset level. Then you have to specify the metadata of the first service of the asset that will be created together with the asset. You have to put a price on that service. You can also specify an additional description of the asset in a different form, for instance. Then you'll have the preview available just to see how the asset will look like. And then you will proceed to the actual publishing of the asset. Then let's see exactly what we mean by this. So I will switch to our stage environment in which I will showcase the publishing of the asset. I have in my MetaMask wallet, I have two accounts. Account one will be used for publishing assets, while the second account will be used for consuming assets. So I'm connected with the publisher account. So let's see how we publish an asset. So from the main screen, we just press publish, and the publishing flow will start. What we need to do here, the asset metadata. First, we need to give the asset a name. Test data set. Okay. Training number 3. You need to provide a description, a better description than the one that I put here. You can also define some tags that will be attached to the asset. You can also mention the author of this of the asset, which is different than the publisher. So the author can be the one that actually created the file that is behind this asset, while the publisher is a different entity. Here you can see the type of the asset. Is it either a data set, or an algorithm. I will first publish a data set just to see how it looks, and then I will go through the same flow for an algorithm. You need to have the consent of the data subjects that are described in the file. So you need to check this in order to proceed with the publishing. Then you need to specify the license of this file, of this asset. And here you can either refer it as an URL, as I will do, or you can just upload the file. And this will be stored in IPFS and then referenced in the asset. So I will use an URL, need to validate it. Okay. Once you upload once you define the license type, you have the option to add additional files to the asset. But I will not do it now. Then you have to agree to the terms and conditions of the marketplace in order to continue with the publishing flow. Let's press continue. Now we are defining the access controls at the asset level. And here you need to specify at least the Web3 addresses that are allowed to access it. You can either specify a Web3 address or more, or you can just select allow all addresses. And this means that everybody can access the asset. But if you want to define credentials based on SSI policies, you have to enable it here. Yeah, and another group of inputs needs to be is shown. I will remove the signature because the signature in my credentials cannot be verified, and basically everything will fail if I leave this on. Then you can request for a specific credential. Let's say that for this asset, we want the consumer to present the legal person, the GAIX legal person credential, which is in the format of a JWC. I will not define a policy now. I will showcase this later. Yes, let's continue. Now I'm creating the first service that is attached to this asset. Let's name it service 1. Again, you have to provide a description, which should be at least 10 characters. So I will just do this. Here, you define the access type. Is the service used for download, meaning that the consumer will actually download the file behind this service, or is it for compute data, which means that it cannot be downloaded, but it can be used in a C2D job. Let's register one for download. Then you can specify the provider. Basically, this means you specify the node which will encrypt the asset. And we have 2 nodes available. This is the multi-node market. We have registered the 2 nodes. You can select the node from here, or you can use your own if you want, but I will use the one that we defined here already. Once you select it, you need to validate it to make sure that the node is accessible. You can also see the information related to this node by pressing this button info, and this will retrieve the information defined in the node, such as the legal entity that owns the node, the terms and conditions applied, the privacy policy. So yeah, if you agree with all of this, you can then proceed to defining the actual file that will be served when this service is purchased. So as I mentioned, there are multiple ways of storing files that are accepted by Ocean Enterprise. URL means that the file is available through an HTTP method. S3 means that the file is actually stored in an S3 bucket. IPFS stored in IPFS, and here you have to specify the content ID of that file. Arweave, it's similar to IPFS. GraphQL, basically you are not serving a file, but you are running a GraphQL query, and the result will be returned to the consumer, or you can reference an FTP server, and the file is basically stored in an FTP server. Let's use the URL. I have a file available here on GitHub. Once you enter the file location, you have to press submit URL just to validate that the file exists at that destination. You can also provide a sample file that contains a subset of the information stored in the main file, just for the user to understand what exactly is behind this service. Then you should specify the timeout. Timeout means how long the consumer can access the service since the purchase time. And we defined here for 1 day, 1 week, 1 month, 1 year, or forever. But we can also create very easily in the market access for 1 hour, for instance. Let's take 1 day, the timeout. So that means that when the consumer will buy the asset, it has access to this service for 1 day, for 24 hours. Then you can also define access rules at the service level. And the same applies for the asset level. It can be either a Web3 address, or it can be in the form of an SSI policy. So let's define in the form of an SSI policy. So to access this service, I need to also provide the GAIX EORI credential, and that's it. For some of the file types selected here, you can also you have the ability to define some user parameters that will be passed together with the request to the service, to the file host. This makes sense only for URL type or for GraphQL. Why? Because for URL, for instance, you can register here not a file, but an API endpoint. And this, by using user-defined parameters, you can actually pass specific values to that endpoint. And the way you do this, so you just click this asset, and you then register some parameters. You have to define the type of the parameter. It can be either text, number, boolean, or select is text, but you can select only from a list. It's required, and there is the default value of it, ABC. And we'll see what happens when we buy this asset. Let's press continue. And here we are in the service pricing step, where you put a price on the service. It can be either free, meaning that you don't have to pay for it, or it can have a fixed price. Here you can select the currency in which you want to price the asset. This particular marketplace supports 3 types: EuroC, USDC, and Ocean, which is more for testing purposes, but we added support for it because it was easy for us to work with it. Let's take EuroC, for instance, and put a price of 1 EuroC. Continue. Here you can upload an alternative asset description in a different form, if you want, and it will be stored together with the initial description. I will not do that. Then continue. We are in the preview step, where you will see exactly how the asset and the first service will look like. Yeah. Let's. I'm connected to SSI. Everything should be fine. So let's press continue. Now I'm actually publishing the asset, and there are 3 steps: to create the tokens and the pricing scheme, to construct the DDO, and then it will actually publish the asset on chain. Okay, when I press publish, I need to confirm these transactions in MetaMask. Okay. Now I need to sign a request that will be sent to the node to encrypt the DDO. And the last step is the actual publishing. So what happens now? The asset is registered on chain. And now the indexer component of the node will is crawling the blockchain for a specific type of events. And when it will get to the asset creation event, it will index the asset. And as you can see, now the asset is available in the market. Yeah. So this is the asset that we created. It has a service defined, which was created at publishing time. Now let's add a new service to this asset, and to do this, you have to edit the asset. Press edit button. In the edit mode, you can either change the description of the asset, and not only the description, but also the access controls. As you can see here, you can here is displayed everything that was initially created. Yeah. Or you can edit the first service or add a new service. Let's add a new service to this asset. Service 2. Okay. Again, we need to specify if it's for download or for compute. Yeah, it's for download. Then you have to put the price of it for it. Here you have the price tokens. This time let's take USDC. The price of 1.5. Then you need to define the file that is behind this second service. It can be the same file as in the first service, or it can be a different file. So this gives you a lot of flexibility in giving access to an asset. Okay, let's take a different file in this case. Again, you have to submit the URL. Timeout, let's say for 1 week. Access rules. I don't have to define nothing yet for the Web3 address, but let's say for the SSI policies, I want a different verifiable credential to check. Okay. Then let's think we defined everything that was needed. Let's press submit and create this new service within the asset. Okay, again, we have to confirm transactions in MetaMask. Okay, the service was created. Now the indexer needs to find the event, and soon we'll see um, the new service listed here. Yeah, as you can see, the service was added to the asset. Now let's see how we can purchase and access the services. So for that, I will switch to my consumer account, which is account 2. When I switch the addresses, I have to reconnect to the SSI wallet because I'm with a different account now, and I need to access this account's verifiable credentials and leads. So by clicking SSI, you can see the wallet to which I'm connected with which Web3 address, the date that I select for publishing, and one of the keys that will be used to sign the assets DDO. Let's take a look, a very quick look, into the SSI wallet of this consumer, which is opened here. So we can see that in its wallet we have the consumer deed, yeah, and 5 credentials of different types. All of them are GAIX compliant credentials: legal person, issuer, EO, relay, code, and VAT ID. Okay, let's switch back to the marketplace. So with the consumer account connected, let's go to the catalog. Here I can see that I have I see this asset. I want to buy it, so I will access it first. In the asset details menu, in the asset details screen, I can see the asset and the services that were attached to this asset. Let's say that I want to purchase the first service. I click on it. There is this button, check credentials, which will verify if I am allowed to access the service. Press check credentials, and the request was sent to Ocean Node. Ocean Node identified that the asset has SSI policies defined and send them to the policy server. And the policy server returned the presentation back to the marketplace. And now the marketplace accessed the SSI wallet of the consumer. And if you remember when we published the assets, at asset level, we defined this verifiable credential to be presented by the consumer, and this was defined at service level. So basically, what is defined at service level and at asset level is added together and assessed together for this for the consumer. So now I have to present the credentials, the verifiable credentials from my wallet. Press accept. Then I need to select the DID from my wallet that will sign the verifiable presentation in which the credentials will be sent back to the verifier. So this is the only one. This is the only DIP that I have. I just press confirm, and the policy was assessed, and I passed the verification. Now I can calculate the total price of the asset, which includes the following: the price of the data set, the fees that are collected, which are split into three fees. The OEC fee enabled in smart contracts, the provider fee enabled in the Ocean node, and the consume market fee, which is enabled by the marketplace. And this is the total price that I have to pay. It's €3 and 12 cents, and one Ocean. I have to agree with the terms and conditions and the license terms of the asset in order to actually buy it. Press buy. And now again, I have to perform some transactions and approve transactions in MetaMask. Okay, so the asset was performed, and now I can download it. If you remember, when I defined the first service, I also provided some consumer parameters, and these are displayed here in the screen, and I need to provide some values, and then I can access it. In our case, because it's a file behind this asset, the consumer parameters don't make sense. But in case there was an API behind this service, the parameters would be sent to that API, and the result was retrieved based on the provided values. So press download, and now I can actually retrieve the file that was behind this service. This is the file. Yeah. Okay, then I think this concludes the demonstration for publishing and consumption. Maybe there's one thing that we can do just to prepare the next demo, and let's see how creating an algorithm looks like. So let's switch to the publishing flow, to the publisher account, sorry. Okay, I will connect back with my first account. Let's publish an algorithm this time. Okay, again, providing a name. A description. Now I have to select the algorithm type. And when I select an algorithm, some other fields are displayed, such as the Docker image that I'm using. If the program that is behind the algorithm is written in JavaScript, as it will be our case, I need to select the corresponding Docker image. It can be either one of these ones or a custom one. And if you press custom, then you have to specify the Docker image, Docker checksum, and the Docker entry point. But in our case, let's use the node Docker image. Then we have to specify again the license type. It will be the same in our case. Validate, agree, continue. Same. Allow all addresses. Yeah, that's for this one. Let's not define SSI policies, just to see what happens. Then I have to create the first service of this algorithm data set. Sorry for that. I'll go on. Okay. You can see for algorithms, I can select this check button to keep my algorithm private for computer data. That means that the algorithm cannot be downloaded, can only be run into a computer data job. Then I have to provide again where the algorithm is located. And let me just find the place. 1 second, sorry for that. It will be this file. Yeah, it's a very simple row counting algorithm. Just counts the number of rows in the data set. Submit URL. Timeout, let's say the same 1 day. Should we define? Let's define some SSI policies that service level. Let's take like code. It's strange. Okay, algorithm. Yeah, because the service description has minimum number of characters of 10, I was not able to continue with the publishing. Let's continue. Let's set the price of 1 USDC. Continue. No additional asset description. Continue. Here's the preview. It's an algorithm asset with the access type compute. Okay, let's proceed to publishing. Okay. Okay, approving MetaMask transactions. The asset was created, and yes, we need to wait for the indexer to index the new asset. Yeah, and here it is. And this is an asset of type algorithm for computer data jobs. Okay, now let's continue with our presentation with the second part, which is the computer data demonstration. First, let's go through some concepts related to computer data. What computer data is a way of privacy preserving, meaning that if a publisher wants to allow access to some of its files, but without actually giving the consumer right to download the asset, the publisher can allow the following: can allow the respective files to be used in an algorithm, and the result of the algorithm, only the result of the algorithm, will be returned back to the consumer without giving the consumer actual access to that asset. So the way that this works, I have, let's say there is a data owner which has some data. An algorithm is executed on top of the data, and the results are returned to the consumer. Now let's see a couple of concepts that are used in this computer data implementation in Ocean Enterprise. Here is a more technical detail of what happens. I can come back to this slide if you want once we finish with the presentation. So when we talk about computer data, the jobs are executed in an environment that needs to provide the processing resources such as CPU or GPU, RAM, and disk. The environment itself is provided by the ocean node or by many ocean nodes. Each environment presents the resources that can be used on that ocean node, and it has a maximum job duration. Yeah, so it means that a job cannot run on that machine for longer than the value specified in this maximum job duration parameter. There can be two types of computer data environments. A free environment for which the consumer will not pay. Usually this environment comes with less resources than the paid one, with shorter job execution time, and the paid environment, for which of course you have to pay, which has more resources and a longer job execution times. The environment types are configured by the node owner, and the node owner can decide if he wants to, if they want to provide a free environment or not. So it's up to them to take this decision. The job cost. What does it mean? Each resource in a paid computer data environment has a price, and the price is charged per minute. The job cost is the sum of the prices of the resources allocated for that job multiplied by the job duration expressed in minutes. We should make a distinction between a maximum job cost and the actual job cost. What does it mean? Basically, when a consumer starts a job, they also specify the maximum job duration allocated to that particular job. What happens if the job takes longer than the maximum job duration? The environment is stopped, is destroyed, and the results that were created until that moment will be returned to to the consumer. That's why the consumer needs to be very careful when it chooses the maximum job duration to allow enough time for the job to be executed. And the actual job cost means that is related to the actual job duration of that computer data job. So, for instance, if a consumer wants to start a job and selects a maximum job duration of 10 minutes, and the total cost of the C2D resources is €3, then the maximum job cost is €30. If the job ran for only 2 minutes, then the actual job cost is 2 multiplied by 3 is €6. Yeah, that's what you need to understand when executing computer data jobs. And the last thing that I want to touch in this presentation of the computer data environment is the escrow account. What is the escrow account? It's a smart contract in which the user deposits some money, which will be used by the node that will execute their computer data jobs. So what happens actually? What are the steps involved in using this escrow account? First, the user deposits funds in the escrow account and then initiates a computer data job. The OE node that will perform the job will lock the amount required to run the job for the maximum duration. So basically, it will lock the maximum job cost in the escrow account. Then the node performs the job, and when the job is finished, the node knows exactly for how long the job was executed, and it will calculate the actual job cost. Then the node deducts the actual job cost from the escrow account and will unlock the difference. So if we are referring to the previous example, if the user deposited €30 in the escrow account and the node ran for only 2 minutes, then the node will take €6 from the escrow account and will release the rest of €24 back to the user. So the leftover funds remain in the escrow account, and they can be used by the user either to run other jobs, or they can be withdrawn by the user. And we'll see exactly how this is done in Ocean Marketplace. Okay, now let's see how we can run computer data jobs, and for that I will switch back to our Stage Marketplace. First, I have to switch to the consumer account. Yeah. Okay, now I'm connected with my consumer account, and also I'm connected to the SSI wallet with the same account. Let's go to the catalog. In order to start a computer data job, you need to access computer data, or you need to access a resource that is of type compute. So in the catalog here, I can filter the resources that are dedicated to compute jobs. And I can filter either by datasets or algorithms. Let's start from an algorithm, for instance. So we filter only the algorithms here. Let's take the last algorithm that I created. It was this one. Yeah. The asset details are presented with the services defined for this algorithm asset. I select the first service available. And now you see, because this asset is of type compute, the services of Tide Compute. The Start Compute button is displayed. Press Start Compute, and the Compute to Data wizard is started. So the Compute to Data wizard can be started either from an algorithm, as we did here, or from a data set. Because we started it from an algorithm, in the first screen, you can either select a data set or multiple data sets on which you want to run the algorithm, or you can proceed without a data set selection. So, for instance, if I have an algorithm which returns a result based on some consumer parameters, maybe I don't need a data set. And this is the option that I need to select in that case. But for our example, let's not do that. Let's select 2 data sets. The one that I created earlier. And another one created a couple of days ago. Continue. In the next screen, we will be presented the services of the data sets, of the assets that we selected in the first step. So you see that this asset has 3 services, and the second asset has only 1 service. So let's take the first service from here and the first from here. Continue. Here is a preview of what we selected so far. So we selected this asset with this service and the second asset as well. Next, we need to select the compute to data environment in which we want to run algorithms. Here you can see what is available in that environment. It has a free environment, a paid one. It also has GPUs. And by hovering here, you can see what type of GPUs are accessible through this environment. Then click on the environment to select it and press continue. Here you have some information available about the environment, how many resources are available for each environment, for the free one and for the paid one. Then you can select the currency in which you want to perform the payment. Let's take EURC, for instance. Select the paid compute environment. You can see here that in my escrow account, I also have available 0.3 euro, and the interface identified that and said that for these resources that I selected here, I have enough money in the escrow account, so I don't have to deposit anything more. But let's adjust the environment. Let's say that I want a gigabyte of disk. Yeah. And I want the maximum job duration for my job of 10 minutes. Yeah. Then the total cost of this job for this maximum duration is 3 euro. But in the escrow account, I only have 0.3 euro. So I have to deposit the difference, 2.7 euro. Okay. Then let's press continue, see what happens. Here, if in this step, you can select either if you want to store the results on the node or on a remote storage. Let's select the remote storage, but maybe you can do that later because now I want to showcase some other stuff. So select the job results on the node. Press continue. Now we are in the review and purchase screen, which is split into 3 parts. On top are listed the assets that were selected. So the algorithm and the data sets on top of which the algorithm will run. The C2D resources, the cost for the C2D resources. And here we can see that for 10 minutes, I have to pay €3. In the escrow account, I only have 0.3. So I need to deposit a supplemental amount of €2.7. And the fees attached to this, associated with this job. There is the marketplace fee, the OEC fee, and soon you will also see the provider fee. But in order to move on with this, first we need to see if the consumer has access to the assets that were selected. So for that, it needs to press the button check credentials, and this will initiate the verification flow for all the assets selected. So let's press check credentials. Interesting. Not allowed, check credentials first. Okay. Then it means that there's something wrong with C2D3. And I can click here, for instance. I selected the first one. Yeah. Now we'll do some debugging.
Can you check if the policy server is up?
Yeah, it is up because I tried right before the demo. Okay, let's do something else. Let's go back to selecting data sets and unselect this one. Let's continue with only this one. Selected the resources. Good. Okay. So I have only the one data set and one algorithm. Okay, so the first data set didn't have SSI credentials, and it passed the Web3 address verification, but the algorithm has SSI credential, and it requires the lay code credential. This is the lay code, the verifiable credential retrieved from my wallet. I selected, accept, I select the deed, which will sign the presentation, confirm. It passed the verification, and now I'm able to purchase and execute the job. What I want to share to show you here, once the credentials are verified, they are valid for only 10 minutes from the verification moment. If this time expires, you have to verify this to perform the verification again. Okay, let's continue then. In order to continue, you have to agree with the terms and conditions of the marketplace and with the terms and conditions of the assets. And if you want to select to see the terms and conditions of the assets, just press on the asset. It will open a new tab, and here you can see the license file. Let's go back to this screen. I agree with the license terms as well. Then the calculate extra fees button is displayed. What are the extra fees? Are the provider fees, and they were not. They could not be calculated before the credentials are checked. because calculating them requires valid access to the assets. That's why it is done in a different step. So press calculate extra fees, confirm. Okay. The extra fees are now listed here. You see provider fee dataset and provider fee algorithm. And now you can see the total amount to be paid in 3 different currencies in our configuration. Because we have assets priced in USDC, we have assets priced in EURC, and the computer data environment priced in EURC, and the provider fee is expressed in Ocean. So buy compute job, and this will start the process of buying the assets, of depositing the funds in the escrow account, and the actual job execution. It will take a while to approve all transactions, so bear with me. Oh, yeah, there are many transactions that need to be approved. That's why we increased the validity time of the credentials to 10 minutes, just to make sure that it is enough time to purchase and approve all the token transfers. Yeah. So now the compute job is started. We can see it here in the asset details. By pressing refresh, you can see the state in which the compute is right now. Running algorithm, publishing results, job settling. Job settling means that the job was finished, but the money for this job were not withdrawn by the node. If we press details, we can see the details of the job. You can see that it ran for 22 seconds. So I will pay only for 1 minute. And once the settling is done, you can see the actual cost of the job. Job settling, still settling. Okay. From this screen, you can also rerun the same job. So it will restart the computer data wizard with the same assets selected. So it's quite simple to rerun it with the same configuration, with the same assets, not the same job configuration. Okay, it takes about 2 minutes, I think, until the payment is done. So this is just an example of what happens when you rerun the job. So you have the same assets selected. Yeah, it's strange. But then you have to configure the environment. Are we done with? No, it's still in job setting. Yeah, it's done. So the payment was done, and you can see that it cost it was 0.3 euro C. So I deposited 2.7 plus 0.3 that I had in the account equals 3 euro C. The job was 0.3. So available in my escrow account is the difference, right? 2.7. So now I can use this amount in the escrow account either for future C2D jobs, or I can click here to withdraw the amount. And in this way, the money will be moved back to my account. Again, we have to wait because a blockchain transaction is performed and takes a while. Okay, now I retrieve the money. I have zero amount in my escrow account. What else? Let's see what happened with that data set that I created earlier. Data set for C2D. So now we can start, for instance, a job from starting from a data set, right? So I selected a data set of type compute. I see the services, all of them are for compute. I put in the description here that this service is accessible, for legal persons from Romania. If I check my credentials in my SSI wallet user interface, I see that for my legal person account, I have country code Romania. So how is this enabled in this verification? How is it enabled in the service? Basically, what I did, I defined a custom policy for that credential, and I will show you exactly how. So I will switch back to the publisher account. Actually, this was published with my account here. Yeah. So edit asset. If I take a look at service one, I can see that this service this one has only the legal person. This requires only a credential, but I think I defined for the other one, for this one from Germany. Yes. This one defines a custom policy. So for that particular verifiable credential, it checks that this parameter within the verifiable credential, headquarter address dot country code equals with this value, which is Germany, right? So normally, if I try to access it with my credential, which has country code equal with Romania, I will not be able to access it. Okay. And so then I guess that's with the presentation, and I will turn off the recording. And now we can switch to questions and answers.